Our third method to find Norton and Thevenin equivalents involves finding VOC and ISC. And before we go any further, when I was an undergraduate, I found it confusing to know, do we need to find VOC or ISC or ISC or IOC? How does all that work? Just as a reminder, OC stands for open circuit. SC stands for short circuit. If you've got a circuit, any kind of circuit, I'll draw it here with this black box and two wires coming out of it. You can think of four possible combinations that we could measure. VOC, V short circuit, I open circuit, and I short circuit. And how do you remember that the ones that you need to find are VOC, ISC? It's actually pretty easy. They're the only two that make sense. V short circuit doesn't make sense because you know that's going to be zero. The voltage across any short circuit is zero, so not interesting. Similarly, the current through an open circuit isn't very interesting because we know it's zero. There can be no current through an open circuit. So the only thing that you can measure, the only thing that could be non-zero is VOC and I short circuit, and those are the two that we need to find. So let's do this now with a practical example. This is the method that you need to use if you've got dependent sources. And you can have any number of dependent sources, but you've got to have at least one independent source to make this method work. Let's find the Thevenin equivalent of this circuit with this dependent source. So our first step is to find VOC. So to find VOC, we can use a nodal or we can use a mesh. Let's start off by seeing which is easier. Since we're trying to find a voltage, VOC, if we define the bottom to be ground, then that whole top node we've defined to be VOC. And since we're trying to find a voltage, nodal would be nice because it gives us voltages directly. How many unknown nodes are there? There's just one here. So that seems to be the clear winner. If we did meshes, we'd have two meshes we'd have to work with. So summing current's positive, exiting that top node. The current going down here is -3. The current going down here is VOC divided by 2. The current going down here is -1/2 I1. And all that has to be equal to 0. So that's our nodal equation. Because we've got a dependent source, we have to have as many extra equations as we have dependent sources. We need one extra equation, and there's no rule on finding that extra equation. We just have to use heuristics. But it should be clear that we can combine those three components, I1, VOC, and 2, to find the relationship that I1 is equal to VOC over 2 just by Ohm's rule. So now we've got two equations, two unknowns we can simplify. We could make a matrix, but I think this is easier to do just by simplification since we know what I1 is equal to. So let's substitute in that equation in on our left where we see I1. We have VOC over 2 minus 1/2 our I1, which is VOC over 2. And we'll bring that constant 3 out to the right. And now we've got one equation and one unknown, and we can solve it. Let's multiply everything through by 4, and we have 2 VOC minus VOC equals 12. So all we did was we multiplied the entire thing by 4 there. And now we can simplify our VOCs, and see it's equal to 12. So that's our first part of the problem, is to find our VOC. Our next part of the problem is to find I short circuit. So we're going to have to redraw our equation in that time region. Now we'll short the output, and we want to find what I short circuit is. Before we do anything with this circuit, nodal or mesh, it's always a good idea to see if we can combine any features of it. And of course we can't combine this resistor with anything or else we'll destroy our I1, and that means we won't be able to calculate our dependent source. But our sources are both moving in the same direction, so we could just as well combine those two into a single source that's 3 plus 1/2 I1. And then we've got this I1 source going down here. And our question is, what is our I short circuit here? Although we could figure out what the currents through each of these branches are using the current divider equation, hopefully it's clear just intuitively that all the current will fall through the short. And that means none will fall through I1, none will fall through the 2 ohm resistor, and so I1 will be 0. And we can just as well rewrite this section as just 3 amps that's all falling through I short circuit. Now that you've found both the open circuit voltage and the short circuit current, now we can find our equivalent, which by Ohm's law is equal to VOC over I short circuit, which is 12 over 3 or 4. And now we can draw our Thevenin equivalent as our VOC, which is 12 volts, with a series 4 ohm resistor. And this is our Thevenin equivalent using method 3.